interesting. Josh is really someone who crosses over between open source communities. He helped create OpenKinect and the Open and libFreeNect libraries, as well as someone who's really active with the Microsoft Kinect SDK. So he's really a bridge between lots of different kinds of people who are using the Kinect device and other kinds of technologies. Josh has a blog, Deconstructing the Natural User Interface, and is currently writing a Manning book, Natural User Interfaces in .NET. He's the technical director of the InfoStrat Advanced Technology Group in Washington, D.C., and he specializes in using natural user interfaces for enterprise collaboration and education. So I'm going to, you are up.
All right, so I'm going to give a little bit of overview of the different types of projects that I work on, both in the open source community and the community at large, as well as at my job, my day job. Then I'm going to do very, very quick demos, and hopefully all of them will work, but we'll see what happens. So, to start out with, I'm one of the Microsoft Surface MVPs, and basically that means that I've contributed to the community significantly, and Microsoft has recognized that. And I'm hoping that they make a Kinect MVP. But I've been doing multi-touch development since 2008, and since expanded into Kinect and other non-traditional interfaces. I've been doing non-traditional interfaces since college, so this has really spoken to me. I'm lucky enough and fortunate enough to be able to do this full-time as my job. So I'm very lucky in that way. And I'm almost done writing my book, which is Natural User Interfaces in .NET. So if you have any interest in .NET and natural user interfaces, it's great. But even in general, I have a lot of good info about NUI in that. So, and I'll have a discount code at the end for that. I'm very excited about Kinect. Kinect really is interesting because it's not new per se, because there's been over 20 years of research in image processing and people tracking, but it's only, I probably need to update the number of months since Kinect launch, in fact it's 12, but 11. But Kinect has really ushered in a wave of Kinect hacks that is because Kinect is so inexpensive and easily available and easy to program. And now instead of different research institutions being the only places that can do this cool research, it's now almost everyone. I started the OpenKinect Community, so basically brought everyone together to working on a single library. We published the first library for Kinect on PC, which is libFreeNect. And there were a lot of people involved in that, doing all kinds of different projects with it. And I've lost count of how many different projects have been posted with that. And now we have the other SDKs as well, the OpenNI for PrimeSense and Microsoft Kinect Windows SDK. And as far as the different types of applications with Kinect, there's lots of different applications, obviously gaming, some people are doing robotics, there's the MakerBot stuff, and performance art. My focus is really on this bottom row of human-computer interaction, collaboration, and telepresence, as well as data visualization. So how do we use this in the enterprise, for example? How do we use it to make it easier for people to interact and visualize their data, as well as interact with each other socially? So that's really what my focus is on when I'm doing these different things. So I mentioned OpenKinect. And one of the interesting things about OpenKinect is that because there's such a diverse set of people who contributed, everyone has their own personal interests. So it's kind of scratch your own itch ideas. So we have many more than these, many wrappers. So almost any language, if you want to develop with Kinect, then you can use that with libFreeNect. One thing we're missing is skeleton tracking, at least for now. So that's one disadvantage with Kinect versus the other one, but we were the first. One of the things I'm working on at work, and this is partially open source and partially proprietary, but at work I'm working on a library called Motion Effects, and it's basically integrates the Kinect SDK in with the multi-touch libraries. So you can take a multi-touch application and add a couple lines of code, it becomes a Kinect-enabled application. And I'll show some of that, but that also lets us do things like take the same application and run it on Microsoft Surface, which is a table multi-touch computer, or on a multi-touch regular PC or laptop, or run it with Kinect and have it work in all these different places, and also opens up multimodal interactions. And this is all integrated in the .NET stack with WPF. One thing that this is an ongoing experiment. I'm trying to apply the Microsoft Research body pose recognition paper. I've implemented the algorithm in that paper and am applying it to hand pose recognition. And so what we're looking at on the left column is the depth data. The center is the training data, the ground truth. And so when I train the algorithm with those two, then it can recognize and identify the different parts of the hands. So with Xbox and on PC, Microsoft is using it for the whole body, but I'm using it for the hands. And there's limited range where that can work, but trying to figure out how exactly we can get a little better fidelity rather than stump mode for most of these applications. So we can, we're using motion effects and the Kinect for Windows SDK and the Surface SDK and adding all these things together and creating really interesting applications. And so I'm going to show some of those. I was invited to the Kinect Code Camp, which took place for 24 hours before the launch of the Kinect for Windows SDK. And so there were about 30 of us invited to Microsoft Campus, and we showed up, and they gave us the SDK and said, build something cool, and in 24 hours we're going to broadcast you live on Channel 9, which is Microsoft's live streaming kind of show or website. And so lots of people made different types of applications, and there are a range of students and researchers and professionals there. The application I created was called Conductor, and we self-organized into teams, and teams of 3, and we found out that my other 2 teammates and I had a shared background in music. So we decided to do this music-themed idea that I had. And basically you can conduct a virtual symphony orchestra, and it'll follow the tempo and follow the volume. So I'll show that as well. That's my book. So here's where I'm going to break into some of the demos. So I was controlling PowerPoint, obviously, with the Kinect. And this is a basic sample application. It's tracking my head and my hands, and when I go past the threshold here, it sends a right gesture, which basically pushes the right arrow key for the foreground application. And when it's PowerPoint, then it goes to the next slide, or back a slide, which is helpful when I accidentally gesticulate too much. And this sample is available on connectpowerpoint.codeflex.com, so that's open source. Next demo is Conductor, and Conductor, and that was Tchaikovsky's A-Piano Overture. So next demo is one of the demo applications for the motion effects framework. In our multi-touch work with Surface, we do a lot of work with maps, and conveniently enough, enterprises are interested in showing their data on maps. I'm going to get out of this one. Seems to be interrupting my demos here. There. So this is actually a multi-touch control, and adding a couple lines of code and changing around the styles slightly, it becomes a Kinect-enabled control. So I can navigate this map and go into different areas of the world, and we have different ways to interact with the controls here. So let's see if I can get one of these to go. There we go. So we can interact in different ways here. So that's one example, taking a multi-touch app and turning it into a Kinect app. One thing you have to be careful about, of course, is that some of the metaphors that we use for multi-touch, like pinch manipulation, it can work with Kinect, but it doesn't always produce the best experience. So it'll work in limited ways, but if I need to zoom in a lot, I'm like swimming for a long time, and it's tiring. So we have to think of different ways to interact with different types of input devices. This application is also using the motion effects framework, and the scenario here is physical rehabilitation. So suppose that you have injured your shoulder and you need to go to physical rehab 5 times a week and do certain exercises. Well, one thing we could do, both at rehab or at home, maybe you can do this at home with your own Kinect, and it sends the information to the doctor and they evaluate it. So I can select let's see if I can get this to go. There we go. So I can select an exercise and it'll guide me through, and I say I need to get to a certain position with one joint or another joint, and I can see real-time feedback, and I can't cheat because it's measuring against my body. And I can go through the different exercises and save the information and make an interesting way to use Kinect in the medical industry. Still work in progress, but this is something I've been working on here this week. So let's see. Basically, Kinect has the RGB data, and we've seen these point clouds before, but when we add depth data, we can navigate around this virtual space. We can move the camera around. And so I could change the perspective so that the camera's near me or in front of me or wherever I want. But I can also make it automatically follow me. So it's placing the virtual camera about 1 meter in front of me, and it's tracking my skeleton. And even when I turn, I'm facing the laptop screen now, and I can't see part of my head. You can't see through me, but we could maybe combine multiple Kinects to account for that. But it'll track me and place the camera wherever I'm looking. And where we're using this is in teleconferences. So suppose you have a large LCD display and you want to have a remote video call with someone else at a different site, and you want to talk about some information. Well, with a regular video camera, or regular webcam, you kind of get like a top-down view of their head, and you can see them, but you're not really having the same level of collaboration as you would if you were in person, where you could make eye contact with them and read their facial expressions a little bit better. Well, with this, you can look into the screen and make eye contact with them, and this is kind of like mirror mode right now, but we can do this from one point to another point, or to several other places, and have much better collaboration because we can see and communicate just like we would in real life. So that's about all I have. Thank you.